In 5.4, we're talking about function notation, which is just another way to represent a function. So our learning goals: I will evaluate, solve, and graph functions. Written in function notation. And also, I will compare graphs of linear functions. So we're back to this linear function idea. So to start off with, what is function notation? Function notation for a linear function is going to look like this. That is function notation for a linear function. And as you should notice, this is almost exactly like slope-intercept form. The only difference is instead of y equals mx plus b, we have this weird f with parentheses. The way that we read that out loud, we say f of x. So this is not saying f times x. Instead, f is standing for our function, and what's in parentheses is our input. So this is saying, with my function, when I put in x, I'm going to get out m times x plus b. We don't always have to use f of x. If we're talking about multiple functions, we might call one f of x, we might call one g of x, we might call one h of x. So that would be showing three different functions, but these all have the same input of x. So to start off with, we're just going to talk about evaluating functions. So for example 1, we're going to evaluate f of x equals 3x minus 8 when x equals negative 2. So what that's saying is, when our input is negative 2, find out what our output is, or find out the value of our function, and that is the subtraction sign. So the way that I show that I'm putting negative 2 in for x is I'm going to write it like this: f of negative 2. Our input is negative 2. And then everywhere I see an x, I'm going to substitute negative 2. So that's going to equal 3 times negative 2 minus 8. 3 times negative 2 is negative 6 minus 8. Negative 6 minus 8, or negative 6 plus a negative 8, is negative 14. So what I would say for my answer is I could say f of negative 2 equals negative 14. Or when I put negative 2 into my function, I get out negative 14. So we're really just using methods from before. It's just using slightly different notation where I'm actually showing my input. In example 2, instead of being given an input and finding the output, I'm given what my function needs to equal, and I need to find the input, or I need to find the independent variable. So this is telling me that I want my function 3x minus 8 to equal negative 5. So we have g of x equals 3x minus 8, and I want to know, what does x have to be to make this equal negative 5? So I'm going to use my same methods that I used in earlier chapters to solve an equation. I'm going to add 8 to each side first. Negative 5 plus 8 is 3. Divide each side by 3, and I'll get that x equals 1. So when my input is 1, I get out negative 5, and that's what the question was asking. What's the value of x to get negative 5? In example 3, we're asked to graph a function. This is a linear function because it's set up as mx plus b. We can graph this by using the same steps we did before, where we graph our intercept, which is 2, go down 1 over 2, down 1 over 2, connect them. We can also do it by making a table of values. So I can make an input-output table, and I'm going to use my function notation. My input is x, my output is f of x, and I can pick just a couple of points. Let's pick -2, 0, +2, and how about +4? So you'll notice I'm picking even numbers here because I'm going to have to multiply by a -1/2. And if I pick even numbers, I won't have any fractions to deal with. So when I put in -2, I have -1/2 times -2. That gives me a +1, and 1 plus 2 is 3. When I put in 0, I get out 2. When I put in 2, I have -1 plus 2, which is a +1. And when I put in 4, half of 4 is 2, that's a -2, plus 2 is 0. So of course you can show your work and write all of those out if you want to, just to check your work and make sure you did this correctly. You'll notice I'm counting up by 2's here, I'm counting up by 1 here, so that would be a 1/2 slope. I'm sorry, I'm counting down by 1, so -1/2 slope, which is what it should be anyway. So I can graph these points. -2, 1, 2, 3, 0, 2, which is my intercept, which I can tell by looking at the equation, 2, 1, and 4, 0. I can connect these points because there's no context here. I'm just given this equation. This is a continuous domain. And there's the graph of my function, f of x equals -1/2 x plus 2. And I did that by making a table of values. Throughout the rest of algebra, we're going to be talking about what are called parent functions and then translations of those parent functions. So basically, we have a whole family of functions here that are all linear. Our most basic linear parent function is f of x equals x, which is just a line with a slope of 1 that goes through 0, 0. So our parent function is going to look like, let's see. Our parent function is going to look like this. This is f of x. And what we can talk about is every other graph that has a slope of 1 has f of x equals x for our parent function. But we could say, like, if we had g of x equals x plus 2, that's just going to be this graph shifted up 2. And remember, another word for shift is a translation. So this graph, g of x equals x plus 2, is a vertical translation. Up 2 units from the parent function. So if I wanted to draw this graph, I just go up 2 units. And let's make sure those are kind of connected. 1, 2, yep. So there's my vertical translation, and we'll call that g of x. So a vertical translation is just moving our graph up or down. You'll notice that these graphs have the same slope, they just have different y-intercepts. So if you're asked to describe, or if you're asked to compare a graph to the graph of f of x, in this case my comparison would be, g of x is a vertical translation up 2, or it's shifted up 2 units. We could also have a shift down. We could shift down 3 units if we wanted to. And that graph would look something like this. Let's call that h of x. So my equation for h of x would look like x minus 3. This is a shift or a translation down 3 units from my parent function. So that's the general idea here, and you're just going to be comparing or basing everything on that f of x equals x and just describing how your new function, g of x or h of x, how they're just a translation or a change from the original parent function there.